In this video, I'll be showing you what software I use to run the CNC machine, kind of an overall view of my CNC machine, and then a very quick overlook of the control panel I actually built to run my CNC machine. So hopefully after reviewing this, you'll get some ideas of your own and figure it out. And you know what, if you see something in here that you disagree with, or you think I could do better, please give me a shout out. Again, I am no expert when it comes to electronics or CNC machines. So hopefully you enjoy it. So to run my machine, I use Universal G-Code Sender on just an old laptop. It actually works pretty well. The Universal G-Code Sender works really good with GRBL shields. It's free, which is the best part about it, and you're able to load jobs that you make in, let's say, MakerCam or Easel CNC or any of those open source software programs. I'm cheap. This is just a hobby for me, so I don't want to invest in some of those more expensive software options. Even though I'm sure they're better than this, this works just fine for my needs. This machine is 3 feet wide and 4 feet long. The cutting surface is a little less than that, obviously, because the gantry can't go all the way on the Y-axis and the X-axis. But it's a pretty good build area, as you can see. All of the MDF that you see that's cut has been cut by the machine during a surfacing process. So it's a pretty big cutting area. So I built my machine using aluminum extrusion. This is V-slot aluminum extrusion, and they call it V-slot because, let's see if we can see here, there's chamfered edges on the inside of this, which actually make a V. And the company who sells this also sells wheels that have chamfered edges that match up really well in that V slot. And it keeps the whole gantry from moving, left and right. It keeps it really tight. Another great thing about this is you have wheels on top that take the majority of the load, but then underneath, you've got more wheels. And these wheels are ran on eccentrics, and you can spin those eccentrics a little bit and really tighten this whole plate onto the rail so it doesn't pop off. And it slides really very easily. Very little resistance, which is what you want. You don't want your motors to have to work a lot just fighting to get your gantry moving. So my X-axis and my Y-axis on the CNC machine are controlled by a rack and pinion design. I did not come up with this myself. The company that I bought the linear rail from actually sells these motors and shows the rack and pinion connection. And it's actually pretty useful, and it's really easy to do. So basically the timing belt comes down, and it goes down here and goes onto the motor, and the motor can crank it, and it pulls the machine left and right. Now I'll move it a little so you can kind of see what I'm talking about. So you see how the belt stays in the same position relatively, but the motor moves based on what it's spinning, which direction it's spinning. So your Z-axis has to be pretty precise whenever you're running a CNC machine, and it also has to hold a lot of weight because your router's on it, and that's quite a bit of weight on it. So I opted to go with the lead screw type. So this is just a shaft that I'm going to spin this, and it's going to be hard to see. We'll try it. You can see here it spins, and it makes the Z-axis go up and down. And again, I chose this because it's a little bit more robust, it's a lot more accurate than using timing belts, and it seemed like just a good fit for my machine. This is a picture of something I have cut on my CNC machine. It's just a basic wood cutting board, but I think it just shows how detailed you can get using very entry-level parts that I have used. The next few video clips are going to be me showing how precise of a CNC machine you can make using the entry-level parts that I have used, such as the GRBL shield and the V-slot aluminum rail. Alright, so I've got the dial indicator set up on my Y-axis, and I have zeroed it out. So my machine is currently set to step in increments of 1 inch. So I'm going to step it 1 inch on the Y-axis towards us and see what happens. You can see, running the GRBL shield, we're able to get right dead on the money, 1 inch. Now let's step it back away from us, make sure we're still calibrated. I call that one a success. Now let's go to the X-axis. So now I have the dial set up on the X-axis. Again, the machine's set to step in increments of 1 inch, so we're going to step the machine to the left 1 inch. And we're right on 0. Let's step it back to the right 1 inch, make sure we're still on the money. And it looks like we are. So now I have the dial set on my Z-axis, and to test my Z-axis, I'm going to keep my router actually still on the Z-axis. I want to make sure it's still accurate with the weight of the router on there. So I have put the dial on, it's bolted on. Let's see what happens when I tell it to step down 1 inch. Up, yep, that's pretty much dead on. Let's go back up 1 inch. Yep, that's it. So this is the control panel I mocked up for my CNC. My control panel is basically a NEMA 3R enclosure, and it holds all of the electronics needed to run my CNC. The electronics includes like a DC power supply, my Arduino's in there, the GRBL shield that goes on my Arduino is obviously installed in there. There's also some other relays and other bits and bobs that help make the machine run. So this is an example of one of the 5 limit switches I've installed on my CNC machine, and I'm going to try not to make the camera shake too much, but I 3D printed a bracket and then I installed these cheap limit switches, and if the machine comes too close and hits it, you might be able to hear it tripping. And hopefully this doesn't make you a little too sick when I pan the camera, but if you come over here and look on my control panel, every time I hit that limit switch, the light turns off on the pilot button you see there. And what that means is that my emergency circuit has been tripped and everything will turn off. That will turn off all of the motors to the CNC machine. That will turn off the spindle. That turns the whole thing off. So it's a good little safety feature whenever you're running your machine while not next to your machine. Here's the limit switch I installed on the Z-axis of my CNC machine, and it's hooked up like all the other ones. It's all in a giant loop, and if this is pressed, it cuts off the loop's power and it stops my machine. I also made this, it's hard to see, there's a sliding bracket that I can move up and down on the aluminum extrusion, and I can set how high I want the emergency stop to be. So basically you want to make sure that this roller is down below where you want your CNC machine to stop if there's an issue. So you don't want it to go too deep. But again, you want this to be set up high enough so it doesn't automatically switch off on accident while you're running your job. Again, just another safety feature. It helps me leave the room with my CNC machine running, which you really shouldn't do, with a little bit more ease. Well, that's my CNC machine. Hopefully you enjoyed the video. Again, I am no expert when it comes to CNC machine or electronics. It's not what I went to school for. It's not what it's not my profession. So please take everything I said with a grain of salt. Please make sure you do everything safely. That is key. Also, I highly suggest wearing earplugs and safety glasses whenever you work with a CNC machine or around a CNC machine. Other than that, hope you all enjoyed it, and see you next time.